Okay, so carrying on today, we're going to look at a few other additional options as far as developing fingerprints on the emulsion side of thermal paper. And what we're going to start off with is using steam. And this kind of came about initially, as the story goes. I was working in the training office at the time at FIS, and one of our laboratory technicians came in with a chicken dinner that he picked up at Swiss Chalet, and he had fingerprints that had magically appeared on the emulsion side of the thermal paper, and he handed me the receipt and he said, "Figure this out." So through research and experimentation, we discovered that it's a reaction with either dry heat and or with steam, and both steam and dry heat will work to develop prints on the emulsion side of the thermal paper. Now, both these techniques that we're going to utilize today are independent of one another, but also they will only develop fingerprints on the emulsion side. It will not have any reaction for developing prints on the back side of the thermal paper. So we'll get started. Put some fingerprints on these thermal paper receipts that we have here. And for our purposes here, we're just going to place them on this chemistry stand here to make it easier for us to keep the paper taut and make it hopefully better success with developing the prints. So I simply just put a couple of clips on there just to hold it kind of in place, and the one at the bottom is just simply to weight it down so that it won't curl up. I mean, you can simply put this, even tape it onto a window surface or whatever and apply steam to it. But the issue with that is then it tends to stick to the actual surface as it starts to get saturated with the steam. So as far as generating steam, in past years we've used this steamer that is fabric steamer, upholstery steamer, but it's given up the ghost here, so we're going to utilize something else. I'm just going to use the steam from the kettle. Hopefully by the next lab, when you're actually doing this, we will have something else that we can use instead, but we will use this. Simply generating steam. So you've got the heat, you've got the moisture, so we've got the kettle. Another option would be using a steam kettle. So I have our samples are hung, and now I'm just going to move the kettle in so that the steam is actually going to be directed upwards here onto the surface. Now you do have to be careful when you're doing this, in as much as if it gets too much of a shock of a temperature and humidity increase, what it will do is it will scorch the paper a dark color, much like our amino acid reagents did with previous illustrations. So I'm just going to try to hit this somewhat indirectly to see if we can get some prints showing up. Very difficult to control it. You can see here that there are some prints starting to appear. Hard to control the steam with the kettle for sure. See, 3 fingerprints are starting to appear there. Yeah, it's very easy to scorch the paper. Let's just set that aside and see what we've got here. Obviously the paper is kind of saturated now with the steam, but as it starts to dry out, it even develops the prints a little bit more clear, more contrast with it. So just hold this up so you can see the developed prints that are on there. Unfortunately, with so many different manufacturers and grade qualities of the thermal paper, it's difficult to have a uniform system of development that will work consistently with every type of paper. And some will work better on some types of paper than others. Unfortunately, it's simply a trial and error because there is no watermark that is on the paper or indication as to which manufacturer it is.